Hi everyone. Oh, we made it. Topic 10. This is the last scheduled topic. Like I promised you, after topic 10, we'll finish off topic 11. There's a little bit of spectrometry that I want to do with you. And then afterwards, we're going to go back and look at every unit and things that we didn't cover for the regular grade 12. I will try my best to cover them all. So I guess you have the whole chemistry package before you graduate. Anyway, let's do topic 10, organic chemistry. Be very careful here for this topic. Whenever you're lost, make sure you ask me questions. You know my office hour. And hey, the good thing is you get to review my lesson anytime you want. So try not to get yourself lost, all right? So there's two parts to this unit. There's the nomenclature part where we're going to name these organic compounds, and then there's the reaction part. They're both hard, if you're wondering. So got to pay attention. But I'll try to take it slow. I mean, we do have a lot of time. Trust me, we do. So let's get right to it. And let's start with functional group. Nice and easy. Okay, what are some of the functional groups that we're going to be talking about together? Well, first, there's alkane. That's the first thing that we're going to talk about, probably today. And in this group, there's also a subgroup known as cycloalkane. Right? These guys involve carbon and hydrogen, and that's it. Okay, you wouldn't see oxygen in them, you wouldn't see nitrogen in them, you wouldn't see phosphorus in them. So just carbon and H. Trust me. This will give you a lot of headaches. And then there's alkene. Okay, which also involve carbon and H. But what's important about alkene is that it also involves carbon-carbon double bond. For alkane, it's only single bond. Number 3, we have alkyne. Again, this involves carbon and hydrogen. And here you'll see certain carbon-carbon triple bond. Okay. Now, you may want to ask, if you have an alkyne, can you have an alkene? Or an alkane? The answer is yes, and that's when it starts to get very, very confusing. We'll get there, don't worry. Number 4, we have alcohol. Some people's favorite functional group. This involves carbon, hydrogen, and oxygen. Wow, oxygen, huh? And the identity of this functional group is some sort of organic hydrocarbon chain bonded to an OH. Okay? Let me just write up here in case you're wondering what R is. R is some sort of hydrocarbon chain or group. Okay? You'll see, because you'll be seeing a lot of these hydrocarbon for the next little while. All right. We probably won't be talking about alcohol until probably next week, because this week we're most likely going to concentrate on the first 3. Hopefully we'll finish the first 3. In case you're wondering, are there more than 4? Oh yeah, there's a whole lot more. Number 5 is called carbonyl. Okay, the carbonyl group is divided into 3 families. Well, before we begin, this also involves C, H, and O. And what's special about these guys is C, double bond O, are always involved. Okay. Now, as I said, the carbonyl group consists of 3 families, which we will talk about later on. I guess I can write it out here. They're called aldehyde, ketone, and carboxyl, which you guys have seen before. You just don't know it's called carboxyl. Number 6, we have amine. Okay, this involves carbon, hydrogen, nitrogen, right? Amine. And this involves, obviously, nitrogen with some sort of R group. Okay. Now this gets actually pretty tricky. So, hey, whenever we get there, I'll show you exactly what these amines are like. Now, I wouldn't go over 7. I would just call them others. Okay? And not other than others is... should I call it reaction? No, I should call it functional products. Okay? Functional products. Like ester, like ether, like amide, like anhydride. These are all functional products. And that's when we will get to that whenever we started doing reactions of alcohol. But in the meantime, we're going to concentrate on these guys in terms of how to name them. Now, how long are we going to be doing this? My projection is we're going to be doing this for 2 weeks. Okay. Hopefully, we'll be done naming these things before Victoria Day. Then we can move on to reactions. That's my projection. We'll see. Who knows? Okay. So, for now, we'll look at alkane, and alkyne for this week. And then we'll worry about the rest in the following week. Okay, let's take it slow because, as I said, once you're lost, my goodness, it's going to be a long time for you to get yourself caught up. All right, let's start. Let's clear the page. Let's take a look at the first functional group that I want to talk to you about today, and this is called alkane. Okay, let me give you some description about alkanes. Hopefully, you while you're watching this, you're writing along, taking notes. We call this saturated hydrocarbon. Now, hydrocarbon is very simple. This stuff involves hydrogen and carbon, right? Saturation actually means in organic single bond. Okay? Single bond. Now, from carbon 1 to 4, now we'll see what that means. The state is a gas. Okay? Carbon 5 and beyond is liquid. And of course, you're looking at SATP. We're always talking about SATP. Not sure why you would talk about anything other than that. So, That's not always true. Okay, that's not always true, but I think that's best thing we can do. All right, what else do I have to tell you about alkanes? I guess we can start naming these guys. Okay, start to look at these guys in more of a detail type of view. And trust me, it gets a lot harder. But before we begin, I need you to memorize something. I need you to remember some prefix. No, not the Greek prefix, not mono, di, tri, tetra, not the stuff that I asked you to memorize before, but I want you to, as soon as possible, try to memorize these organic prefix. So 1 is called meth. Okay? Meth. 2 is eth. 3 is probe. 4 is but, not but. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. 10 is dec. Now there's 11, there's 12, but why go there when we don't need to get there? Right? So memorize those prefixes as soon as possible. So let's go. We're ready to tackle alkane in terms of nomenclature. So let's organize a little chart. Let's do a little chart. Okay? I have N here. N stands for numbers of carbon. Okay? And then I have various formula. Like, for example, I don't need that much space for this one. Okay, I'm going to make it thinner. I have chemical formula. Chemical formula is both, it's not important. It's important, but not inorganic. Inorganic is pretty useless. So chemical formula, we have structural formula. Now there's different ways of doing structural formula, but I'll just look at it like, let's say, one proper way. Okay, it's a more annoying way. I think your book has it a little easier. And then I have this one. This one I want you to learn, because we're going to be doing this formula after you guys are comfortable with organic chemistry. And then I have name. Okay? So we have N, which stands for number of carbon, giving me a chemical formula. And then we have structural formula, condensed formula, and name. As I said, this one is the most important. This is the one that I want you to get used to, because I'm going to stop drawing this one. Okay? After Thursday, I'm going to stop drawing this one. Maybe up to Friday. You'll never see me drawing structural formula ever again. So get yourself used to condensed formula. Okay? Get yourself used to thinking that carbon makes 4 bonds. Hydrogen makes 1 bond. Nitrogen makes 3 bonds. Oxygen makes 2 bonds. Halogen makes 1 bond. Start thinking about that. You should be able to interpret that very easily now. So, let's move. Let's take a look at N equals to 1. Okay. Now, there is an alkane, I guess they would call it formulation, okay, for the chemical formula. It's called CnH2n plus 2, okay, for alkane. This is the mathematical formula to find out different types of alkane. But I can tell you right now, it's useful for alkane, but it's no longer useful everything after. Especially when it gets a little bit too complicated. That becomes this becomes very useless. But since we're doing alkane, this is somewhat now useful. So we'll use it. So if N is equal to 1, what would the chemical formula be if we were to follow this mathematical formula? Well, C1, which we never indicate the 1, H, 2N plus 2, so 2 times 1 is 2, 2 plus 2 is 4. Oh, CH4. What do you know? We know how to name this already because sometime around September, I gave you this and asked you if you can draw it. You guys drew it. You guys told me it was tetrahedral. Ooh. And we even named it. I told you the name of it. I hope you know why we named it as we named it. If that makes any sense. All right, structural formula. Structural formula is exactly how you would, I guess, interpret it. Okay? Meaning showing the bonds for carbon. Showing exactly how to put together CH4. Now, you don't need to put it in tetrahedral. Okay, that's not important here in organic chemistry. What's important is showing me that carbon can make 4 bonds, and each bond is covalently bonded to a hydrogen. 2 hydrogens, I guess. I don't know. Now, condensed formula. Condensed formula is going to be CH4. Now you may be asking, hey, isn't this just chemical formula? Yeah, it is for now. Hopefully when I do N equals to 2, you'll see a little bit of a difference. Okay, we'll hold that thought. Now, how do you name CH4? We know it's called methane. Okay, I pretty much said it many times during the course of this course. CH4 is methane. Now, why methane? Well, if you remember those prefixes I asked you to memorize 10 minutes ago, 1, which stands for 1 carbon, is called meth. Remember that? Meth means 1, and that 1 means the number of carbon. Well, this is in the functional group alkane, right? So that's why we call it methane. Meth, because it's 1 carbon. Ane, because of the functional group alkane. So I didn't just grab this name out of somewhere. Okay, there's a reason why it's called methane. Okay, all right. Hopefully you're still with us. N equals to 2. Okay. Following the mathematical formula, you would say, hey, that's C2H6. Right? C2H6. How would you draw this structurally? Well, I was told a long time ago, if you have hydrocarbon, you link those carbons together. And you'll notice that, oh, I owe 3 H's to this C because every carbon makes 4 bonds. And here you go. Exactly 6 H's, just like what my chemical formula asked me to have. All right, perfect. That is the structural formula. Condensed formula. Would it be C2H6? No, of course not. Condensed formula is when it will differ. You write C, okay? And you look at this C and you tell me how many hydrogen is bonded to this C? Well, 3 of them, right? Then you look at this C and you put C there. And how many hydrogen is bonded to this C? Again, There's 3 of them. So condensed formula is about the carbon that you're looking at and how many hydrogen or whatever it may be is bonded to that carbon. Don't worry, you will get used to looking at these. And trust me, after 2 weeks of nomenclature, this becomes second nature. All right, hey, let's name it. If CH4 is called methane, what do you think CH3 is called? There's 2 carbon involved, right? 2 means eth. This is an alkane family, so that's ethane. See? Not so bad, right? Hey, let's continue. Let's do another color. N equals to 3. So this will be C3H8. C3H8. Hey, bond all 3 carbons together. Fill the rest with H. So I owe 3 H's to this carbon. How many H's do I owe this carbon? Well, if H's make 4 bonds, that means I owe this carbon 2 H's because this carbon is bonded to this carbon, and this carbon, that's 2 bond, and I need 2 H's to make it 4 bonds. And it should make sense because this carbon will hold 3 H's, and if you count, that's 1, 2, 3, 4, 5, 6, 7, 8, just like what we were asked to do. All right, how would you do condensed formula for this? Hey, just like what we did before with ethane, you start with this C. And you tell me, how many H's is bonded to this C? Well, there's 3. Then you look at this C. And how many H's is bonded to this C? Well, I see 2. Then we look at the final C. How many H's is bonded to this C? 3. Okay. What would we call this? Just 3 carbon. Well, 3 is prop. And being an alkane, this is called propane. We call this propane. Oh, that reminds me. I need to fill up my propane tank. It's gonna be a warm week. I'm gonna do some barbecue. And no, you guys are not invited. Number 4. Okay, this is C4H10. Okay. 1, 2, 3, 4. I owe 3 hydrogen to this carbon, 2 hydrogen for this, 2 hydrogen for this, and 3 hydrogen for this. So structure, condensed wise, this will be CH3, CH2, CH2, CH3. All right. What will we call this guy? Well, let's call him butane. Butane. You guys okay so far? So far so good, I hope. It's different, okay? We learned inorganic nomenclature in October, and that wasn't a challenge. You guys did very, very well. This is a new game, organic nomenclature. So let's do one more, and then we'll call it a day. Oh, that should be great. So let's do a big one. Let's do this one. Let's do 8. Let's for the sake of 8. C8H18. Okay, so we have 3, 4, 5, 6, 7, 8. Okay. Now, you'll notice in some textbook, I think Cognitive does this, where they do this. They don't put in the H's. right? They don't put in the H. It is in the assumption as readers that these are bonded to H. Let's say they're not bonded. If there is a case where it is not bonded to H, but bonded to something else otherwise, they will write that in. Okay, so if you see some sort of scientific literature or some sort of textbook later on in life, and you see something like this, just count the number of carbons, because what's not being indicated, it's going to be by default hydrogen, always. Okay, and if you're going to do condense, oh my goodness, CH3, CH2, 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 1, 2, 3, 4, 5, 6, 7, and 8. Okay, like that. But, some people discover a little shortcut here. You may see this, CH3. And then they open a bracket and write CH2, and outside that bracket, they indicate how many CH2 in this chain. Well, there's 6. And then CH3. You might see that too. That's actually very popular in many textbooks because hey, it's cost saving. Imagine when you have like 20 of these carbon chain. I'm sure you want to write CH3, CH2 18, CH3 instead of 20 of these carbon. All right, 8. You're looking at C8. What would be the name for this chemical formula? Well, hey, octane. Okay, the main ingredient for gasoline. Anyway, I hope you guys are comfortable. Okay, this is the first lesson. This is very preliminary. It gets actually quite difficult starting tomorrow, because tomorrow we're going to start looking at isomerism. Kind of heard that word before, haven't you? Isomer, you know, alpha glucose, beta glucose, that's isomers because they have the same chemical formula, but they structurally looking different. Anyway, I'm not going to scare you today. We'll look at that tomorrow. All right. Have a good day now. Bye.